Welcome back, hackers. I'm Rootmancer, and today we're taking on TryHackMe's Hammer machine. We'll begin with Nmap, uncover hidden paths using ffuf, analyze the web application, manipulate JWT tokens, and write a custom Python brute force script to push deeper into the target. No wasted time. Let's begin. Alright, we begin with a basic Nmap scan against the target. The scan shows that port 1337 is open and running an HTTP service, so that's where we'll focus first. I open the service in the browser and start with a few basic login attempts to understand how the application responds. After testing the login page for a bit, nothing obvious works, so the next thing I check is the page source. Sometimes developers leave useful comments, hidden paths, script references, or small clues inside the HTML. As you can see, we found a developer note inside the page source. The note gives us a useful hint about a directory pattern, so I'm going to use ffuf and fuzz for paths that start with HMR_. After running ffuf, I focus on the responses returning 200 and 301 status codes, because those usually indicate valid or redirected paths. One of the results that stands out is the logs directory, so I open it in the browser. Inside the logs directory, we find an error.log file. I click on it to inspect the contents, and inside the log entries, we can see an email address being leaked. This is an important clue. I copy the email address and move over to the Forgot Password page, because leaked emails are often useful for account recovery or password reset flows in web challenges. After finding the leaked email address, I tried to use it on the password reset page. The application asks for a 4-digit reset code, so my first idea was to brute force it with Burp Suite intruder. However, the application has rate limiting in place, so the intruder attack gets blocked pretty quickly. At this point, I needed a more controlled approach instead of blindly sending requests too fast. So I used Claude Code to help me write a custom Python brute force script that respects the application's limitations and avoids triggering the rate limit too aggressively. After that, I entered the required parameters, such as the target URL, session cookie, and the code range, then let the script run. And bingo! As you can see, we successfully found the reset code. Using that code, I reset the password and logged into the account. But after logging in, I noticed something interesting. The session persistence value was set to no. To make the session persistent, I captured the request with Burp Suite proxy and modified the persistence parameter before forwarding it. After getting inside the application, I noticed that the session is using a JWT token. This immediately becomes interesting because JWTs can sometimes reveal useful information, or even become an attack path if they are misconfigured. Inside the panel, there is also a command input area. I start with a simple ls command to see what files are available, and the output lists several files. One file stands out immediately because it ends with a .key extension. At this point, I suspect that this key file might be related to the JWT signing process. So I use curl to retrieve the key and then test whether it matches the current token signature. However, it turns out that this is not the signing key for the token we currently have. But then I look back at the JWT header and notice the KID value. Since KID is used to identify which key should be used for verification, I realize that we might be able to manipulate its path. So instead of only changing the payload, I modify the KID value to point to the key file we discovered. At first, I entered the wrong path in the KID parameter, so the token did not work as expected. This was a good reminder that with JWT key path manipulation, the exact file path matters. After correcting the path and pointing KID to the proper key location, I re-signed the JWT with the modified payload. This time the application accepted the token, and our role was successfully changed from user to admin. Now that we have admin access, I go back into the application and check the available functionality again. From there, we can access the protected area and finally retrieve the last flag. And that wraps up TryHackMe's Hammer machine. If you enjoyed the video, like, subscribe, and let me know what machine you want to see next. I'm Rootmancer. Stay sharp, and I'll see you in the next one.